So now we're going to look at physical and chemical properties and changes of matter. All right, physical properties of matter would be characteristics we use to describe matter, right? Color, shape, mass, density, physical state. When I say physical state, I mean, is it a solid, a liquid, a gas, or a plasma, which we don't talk about very much. A physical change is a change that can happen that you still have the same substance after it happens. So if you were to melt the cheese would now be melted cheese, but it's still cheese. The same thing with an ice cube. If you melt an ice cube, you have water, which is melted from solid water to liquid water. Boiling, bending, breaking, dissolving. These are all physical changes. Dissolving is a tricky one because I know a lot of students, when they think about dissolving, say, salt into water, they think that they've gone through some sort of chemical change or real change. But in actuality, the salt is still there. It's just dissolved in the water. Like I said, changes of state are when substances go from one form to another. I don't think I really need to cover this, but I just want to make sure we're all on the same page from middle school. Water, for example, is a liquid. If we were to cool water down, it would become ice or a solid. If we were to heat water up, it would become steam or a gas. So the solid form is the coolest of the three states of matter, followed by liquid, and the warmest or the hottest of the states of matter is the gas. Now, we're usually used to using water. However, this could be exactly the same for something like copper. You can have solid copper, which melts to liquid copper, which actually can be turned into gaseous copper, like on the sun. If you think about what these look like, if we were to zoom in at the particles, solid would have particles that were really tightly packed together and nice and neat and orderly. There's lots of different kinds of solids, and we'll get to this later on in the year in chemistry where we talk about crystalline solids and covalently bonded things and how molecules put together. But basically, that's what a solid looks like. A liquid is very similar, except a liquid has the particles have a little bit more room to move, um, and they can slide past each other a little bit easier, and they're not as neat and orderly. However, they still are tightly packed together, which is different than the gas, where the particles are spread out and the particles are not tightly packed together and therefore do not have a definite volume like the solid and the liquid. So a solid has a definite volume and a definite shape, which you can imagine, again, our ice cube as an example. A liquid has a definite volume. I cannot compress the liquid. The liquid has the volume that it has, but not a definite shape. And then a gas has neither a definite volume or shape. Now, a plasma is a high temperature state in which atoms lose their electrons. I'm just throwing it out there because I always have one student that's like, hey, Ms. Robles, there's more than three states of matter. Guess what? There's more than four. There's actually more than five states of matter. So we won't get into those details right now. Here you can see we've got solid, definite volume, definite shape, liquid, definite volume, but not definite shape, and a gas, not a definite volume or a definite shape. Now let's take a look at chemical properties of matter. Chemical properties of matter tell us what the substance is actually made of and how the substance interacts with other substances. A chemical change, for example, is a change in which a brand new substance is produced. You cannot get back. A physical change, if it goes through a physical change, you can get it back. If an ice cube melts, you can refreeze it again. But a chemical change, like the burning of this match, is when you have an entirely new substance that's created. When this is done, you're going to have, a black kind of burned out match, and it's not going to be anything like the original match. That is a chemical change. Here's another example here. This is barium hydroxide and ammonia salts, and I'm just throwing this in front of you because it's, just an example of a simple chemical change in chemistry. What's happening here is you're mixing two solids together. They're getting stirred together. They actually become liquid and they get freezing, freezing, freezing cold. They get so cold that they can stick to a block and freeze it to a block. So that is an example of a chemical change. Evidence for chemical changes might be that you see a change of color. In the example of the match, that was pretty obvious, or anything else that you burn, you definitely see a change of color. You may have a release of heat, or in the example I just gave you of the barium salts, you might absorb heat, which in chemistry means that it gets cold. It may release a gas or an odor. If you also see bubbles, this is an example in chemistry of releasing of a gas or an odor coming from it. Or you might get a formation of solids from liquids. This is called a precipitate, and it is not like precipitation that you would have learned about in your middle school class. A precipitate is when you get two liquids together that form a solid, and it's usually like a powdery solid that's dissolved in a liquid. The law of conservation of mass, we will talk about in the lesson today, but if you would like to write down those definitions, you can.